Welcome back. Welcome back, Cyclone Scientists. Today we're going to be talking about how you determine water quality. So let's go ahead and get started. So, Ms. Sears, what is water quality?
We just went to Bowling Creek, and so we have a good idea of what it's like to be in an area that has pretty good water quality. Now we're just going to look at the specific tests that we do to determine the water quality.
Right. Okay, so let's go ahead and talk about what those tests are. So one of the first tests we do for water quality is we look for something called dissolved oxygen. What's dissolved oxygen all about?
Now, the great thing is you have a fish tank right in your room. So what I suggest is when you go pick up your sick, you walk by the fish tank and look at the water coming in through the filter, and you will see tiny bubbles being pushed down into the water column. Basically, it just means that the water is having the oxygen pushed in, and that's the oxygen that the fish need to live.
All right, so these fish are happy when there's lots of dissolved oxygen.
Exactly.
And if there's not enough, then they are dead. Really important that we have dissolved oxygen. Okay, so how do we have high or low dissolved oxygen? There's a few different physical features of the environment that can affect the dissolved oxygen levels. So let's talk about some of them. The first is how fast the water is moving. Fast water is going to mix with the air a lot more and is going to end up with a lot more dissolved oxygen than slow or stagnant water, which will have very low dissolved oxygen.
And remember, we look for the macroinvertebrates in riffle areas, the areas we notice the water moving quickly around rocks.
Okay, what else besides speed can affect dissolved oxygen?
Temperature is a big one. When temperature levels are high, dissolved oxygen levels are low.
Okay. And the other thing that can affect dissolved oxygen is if you have a lot of dead, decaying organic matter, like dead leaves, dead organisms in the water, that decaying stuff tends to use up all of the oxygen in the water.
Right, because you have small bacteria moving in and eating up all that decaying matter, and there we go, we're using up all of our oxygen in the water column.
All right, so that's our first test. Let's talk about our second test. Number 2 test is
pH.
All right.
And pH, we're looking at how acidic or basic water is. And when we're looking at our water and looking for good water quality, we're looking for levels between and around neutral, where we have it hitting around the 7. So our water quality tests that we did at Bowling Creek say about 6.8. Perfect. It's right in around the neutral level of water. Good water quality.
So 7 is kind of funny because usually either high or low is good, but in the case of pH, it's right in the middle that is the best value. What does it mean if something has a pH less than 7?
If it's less than 7, then it's more acidic,
Okay.
like lemon juice.
Okay, and where are my strongest acids going to be? Are they going to be around like 5 or are they going to be down here around like 0?
Around 0.
Okay, so the lower number, the stronger the acid, and then the reverse is true on the other side.
Right.
The higher into the number, the stronger the alkaline or the base. What kinds of substances are bases?
So if we're looking at bases, we're looking at those ammonia cleaners that we have at home. The ones that smell bad but clean really well, well, that's probably alkaline solution.
Okay, so let's talk about some things that can either raise the pH to make it higher or lower the pH. So Ms. Sears just mentioned some chemicals like detergents, cleaning agents. If those somehow ended up in the water, like if we had a laundromat near the water or something, that could raise our pH and make it more basic or alkaline. But that's pretty rare. The bigger problem is getting lower pHs. So what are some things that cause that?
So lower pHs are caused by high carbon dioxide. So when we have those areas where we have a lot of decaying matter,
like these dead fish right here.
Yes, exactly. We have bacteria moving in, munching up the decaying matter and using up all the oxygen within that particular area, causing a lot of carbon dioxide to be formed and eventually carbonic acid.
Okay.
Lowering the pH.
And the other thing that we'll be talking about more later is this idea of acid rain. When we burn fossil fuels from factories and release chemicals up into the air, sometimes those chemicals can combine with water and then fall back to earth as acid rain, and they can also lower the pH. So those are our two big things. Okay, so we've talked about dissolved oxygen, we've talked about pH. Let's move on to our next chemical test, which is nitrates and phosphates.
Great. So nitrates and phosphates, they're just nutrients for plants. And so what happens with nitrates and phosphates? They make algae grow and grow and grow and grow because algae are just single-celled plants.
Right. And so when these algae go crazy, it can cause some problems. So let's talk about high and low. So where do these nitrates and phosphates come from? Well, nitrates and phosphates, they're nutrients, like Miss Deere said. So they're found in things like fertilizer, things that we put on plants to make them grow, or manure, or even sewage or untreated wastewater. And so if this stuff is somehow finding its way into the water, either through runoff or through leaky pipes, you're going to have very high nitrates and phosphates. And if you don't have that stuff, you're going to have low nitrates and phosphates. Now, nitrates and phosphates cause some problems that are really important to understand. So we're going to take a second just talk about the process or the problems that nitrates and phosphates can cause.
So when we have high levels of nitrates and phosphates, we end up with eutrophic conditions. And basically what it means is that we have these huge algal blooms that cause that plants start growing and growing and growing and growing, and then as they start to decay, our bacteria are moving in and using up the oxygen.
Yep, it all comes back to that oxygen, and when it goes away, the fish die.
Exactly.
Okay, so you want to remember too much nitrates and phosphates, eutrophication. We'll be talking more about that in our next podcast. Okay, moving on to our next chemical test, which is
turbidity.
Okay.
And turbidity is basically just how clean or murky the water is.
Okay. So what are some things that can cause high turbidity, can make the water really murky or cloudy?
So you remember our Bowling Creek tour where we noticed that area of the hill that was all eroded away? Well, the dirt that was once there is now in Bowling Creek. It goes to Jolly Branch and eventually down to Bowling Creek. And it's because there was no vegetation there to root the dirt to the ground. And so it caused high turbidity levels.
And the other thing is, again, those eutrophic conditions we talked about. If there's a ton of algae in the water decaying and dying, that's going to make the water very cloudy too. And so problems with this are it's going to block out sunlight for those plants and aquatic organisms under the water and end up also lowering our dissolved oxygen levels. That dirt can also provide an attachment place for pollutants and can provide sort of shelter for things like bacteria and viruses that we really don't want in our water. And low turbidity is going to be when we don't have all that stuff, when we have lots of plants to hold the soil in place, and when we don't have a lot of runoff or eutrophication. So our next chemical test is
temperature.
Okay, so why should we care about temperature in water?
Because temperature really makes a big difference for the dissolved oxygen levels in our water.
So let's go ahead and take a look at this graph here. So I noticed two lines, one line which represents the water temperature at different times of year, and one which represents the dissolved oxygen. So what trends do you notice, Ms. Deers?
Well, if you look at the red line where it's reaching its peak, you notice that the temperatures are at the highest, and you can go down below the high temperatures and you see, oh my goodness, dissolved oxygen levels are starting to reach their lowest.
Yeah.
So there's a trend that high temperatures can't hold the dissolved oxygen that lower temperature water can hold.
Okay. So some things that can cause high temperatures in water, what we sometimes call thermal or heat pollution, is one, when people use water to cool off factories as a coolant, like this nuclear power plant, a lot of times that warm water is then put back into the lake or river. So we have this big input of warm water coming in. And another way is when there's runoff from storms, because if you think about how hot that pavement is in the summertime, when the water runs on that pavement, it warms up. And then that warm water is going into streams and could lower the dissolved oxygen. Okay, so we just have two more to talk about. Our second to last indicator of water quality.
Runoff. And if we look at runoff, we'll notice that runoff has a direct relationship to turbidity levels. Whenever we have a lot of runoff, then we get concerned about higher turbidity levels, maybe higher nutrient levels in our water. So runoff really does impact other water quality
Our last
issues.
water quality factor is our bioindicators. So my whole class, we already went outside into Bowling Creek and studied our bioindicators. So what's a bioindicator, Ms. Sears?
They're those little organisms that we can see with our eyes and they don't have a backbone. We look at the macroinvertebrates, macro big, so that we can see it with our eyes. Invertebrate, they don't have a backbone.
If we see a lot of bioindicators that are pollution intolerant, meaning they can't take any pollution, we know that our water is pretty healthy and that it must have good dissolved oxygen, good pH, all this other stuff must be good. Whereas if we see low bioindicators, we know that there might be a lot of pollution, only pollution tolerant organisms can live there, the pH might be bad, the dissolved oxygen bad.
And we really have to look at our chemical test to verify what's going on.
Right. Okay, so that's a wrap. So make sure that you study these terms, maybe make some flashcards, and thanks for listening.
See you tomorrow. Bye.